This video is section 4.1, part 1. Today we're going to be focusing on angles and radian measure. And we're going to be talking a lot about the different vocabulary of angles and also the difference between degrees and radians. We'll go ahead and get started with our first objective, which is the vocabulary of angles. Now you'll notice that we're just taking an angle and we're placing it on an x, y axis. This is going to be an angle in what we call standard position. There's a few important things to notice here. The first is that the vertex of the angle is on the origin of our graph. So it's on the x, on 0, 0. Now, one side of the angle we'll call the initial side. The initial side is going to be on the positive x-axis. The other side of the angle is what we'll call the terminal or ending side of the angle, and that's going to be anywhere then in quadrants 1, 2, 3, or 4. You'll notice that we use an arrow to show the direction the angle is going. That's going to become important to us in determining if it's positive or negative. We'll talk about that next. And we like to name angles with Greek letters. So for example, I can call this angle theta. Now, the way that we name the location of angles is based on their terminal side. If we remember our quadrant numbers, 1, 2, 3, and 4, the angle theta, I would say, is located in quadrant 2. The reason theta is located in quadrant 2 is because its terminal side, or its ending side, is in quadrant 2. So that's why we say theta is located in quadrant 2 in this case. Now, this is an example of a positive angle. In the next slide, we'll see the difference between positive and negative angles. You can see that an angle just looks like an angle. It's all going to depend on that arrow. If the arrow is showing the angle moving in a counterclockwise position, that makes it a positive angle. So I can draw a positive angle here. I can put the initial side on the positive x-axis, and I could draw that positive angle ending anywhere I want. The key will be the arrow, showing that it's moving in a positive direction. We could call this one, for example, alpha. Now, a negative angle, its arrow is going to show that it's moving in a clockwise position. So if the angle's going clockwise from the initial side to the terminal side, then that's what we would call a negative angle. I can use the same angle we drew down here and move it the other way. And this I could call maybe beta, and this would be an example of a negative angle. That would be a negative amount of degrees or radians. So positive angles move counterclockwise, negative angles clockwise. Now let's talk about the difference between degrees and radians. We did a little bit of work in this in class, and we'll just look at some circles for a minute, starting with degrees. One thing to remember is that if I go all the way around the circle, I've gone a total of 360 degrees. That makes halfway around the circle 180 degrees. So halfway around will be 180. If I go half of that, I've only gone 90 degrees. And down below, we could say that would be 270 degrees. Now, 270 would be 3/4 of the circle. Would be an example of 270 degrees. We're used to working in degrees with our circles, but the key we want to talk about today is radians. Now, radians depends on the radius, remember. It's how many radiuses, the length of the radius makes up one radian. Now, because it doesn't really make sense and it doesn't go around an even number of times, that's where we start to use that pi involved. One thing to remember is that all the way around the circle is a total of 2 pi. Now, this comes right from our formula for circumference. Remember, circumference of a circle is 2 pi r. And in this case, we're talking about a unit circle, meaning a radius with a unit 1. So if the radius is 1, that means that the circle all the way around is 2 pi. Now I don't know 1, is it 1 centimeter? Is it 1 inch? Is it 1 Smarties? I don't really know, but I just know that the radius is 1. Now, that means that if I only go halfway around the circle, that would be a total of pi radians. Which means a fourth of the circle, or just halfway around the top, would be half of pi, and we like to call that pi over 2. 3/4 of the way around then would be 3 pi over 2s. 3 pi over 2. Now, in terms of radians, we're always going to leave it in terms of pies. We're not going to use our radians in decimals in this case. We'll always use fractions with pies involved, and that's why fractions is going to become so important in this chapter. Here's an example I want to take a look at. I want to know the radian measure of theta for an arc with a length of 20 inches and the radius is 5 inches. So let's take a look at this picture for a minute. I have a picture here and I see the arc length is 20 inches long and I know my radius is 5 inches. Now remember, the definition of radian is how many radiuses does it take to make up that angle or that arc. Since my radius is 5 inches and I want to know how many of those 5 inches are in 20, we can just say, you know what, let's take that 20 and split it up into groups of 5. So 5, 10, 15, and then there's 20. So it looks like, to me, it takes up 4 radiuses to make up that angle theta. Since that's the case, we can say, in terms of radians, theta is going to be 4 radians. Now remember, the way we did that is we took our arc length of 20 and we divided it by 5, and that's how we got the 4. So we took our arc length and divided it by our radius. And that's how we got how many radians made up that arc length. All right, moving on now. We want to, lastly in this video, talk about converting between degrees and radians. And actually, before we do that, let's go back for just a moment. And I'd like to assign you a free response question right now. So on your Google form, I want you to go ahead and on your Google form, I want you to explain to me in your own words, what does it mean? What is a radian? What does it mean to be a radian? So for your free response question, I want to know, what is a radian in your own words? Okay, back to that last objective for today, objective 4, converting between degrees and radians. A few minutes ago, we reviewed the fact that pi radians is 180 degrees. Those are the same thing. Remember, 2 pi will be a total of 360. So, if I want to convert from degrees to radians, I'm going to multiply my degrees by pi over 180. If I want to go the other way, we're going to multiply by 180 over pi. And so we're just going to use these ratios. Remember, pi and 180 are the same thing. The way that I like to think about it is that if I have my answer if I have my starting value in degrees, I want to get a pi in there, so that's why pi is on the top. If I have radians, I want to get rid of the pi, so that's why it's in the bottom. And that's the trick that I use to help me. So let's go ahead and take a look at a couple examples. So here's the first one, 135 degrees. And I want to convert this from degrees to radians. So remember, the rule then says we're going to multiply by pi over 180. So let's go ahead and do that. Let's take 135 degrees and multiply by pi over 180. Now when I do that, it looks like the pi is going to end up on top. Remember, we're multiplying fractions, so we'd multiply straight across the top, and then the 180 is going to end up in the bottom. We need to do a little simplifying here. 135 over 180 is 3/4. So my answer here will be 3 pi over 4. Now, one thing you can do in your calculator if you want to simplify this is you can put 135 divided by 180 and see what that equals. And then you can press that math button, and then you want the fraction button, and that'll turn that into a reduced fraction. All right, so we'll do the same thing for negative 120 degrees. Again, we're going to multiply by pi over 180, so the 180 is going to go in the bottom. We'll reduce negative 120 over 180, and that's 2/3, so we get 2 pi over 3. Looking at one more, negative 150 degrees. Again, same process, multiply by pi over 180. Just to show you some tricks for simplifying here, the zeros would cancel. 15 over 18, let's see, 3 goes into both of those, and we can get 5/6. So the answer here is negative 5 pi over 6. And once again, you could use your graphing calculator to help you, or any calculator for that matter, to help you reduce that fraction. So again, to go from degrees to radians, we're going to multiply by pi over 180. Now we'll go the other way. We're going to go from radians to degrees. So now remember, we multiply by 180 over pi. And remember, the goal is to get rid of the pi, and that's why we want the pi in the bottom to help them cancel out. So for part A, we'll start with pi over 2, and we'll multiply by 180 over pi. Now really what's going to happen when I multiply those is we'll multiply straight across the top and straight across the bottom. The great thing is the pi's are going to cancel out, and 180 divided by 2 is 90 degrees. And if you listened a couple slides ago, you might remember that pi over 2 is the same as 90 degrees. They're in the same position. Part B, 2 pi over 3. Again, the same process. We're going to multiply by 180 over pi. Now, I'm going to cancel out the pi's again right away. And you could do 2 times 180, which is 360, and divide by 3, and you'll get 120 degrees. Another way to get the 120 degrees is to say, you know what, 3 goes into 180 60 times, and 60 times 2 is 120. So lots of ways to get to these answers. Lots of ways to reduce these fractions. And the last one, negative pi over 3. Once again, we're going to multiply by 180 over pi. The pi's will cancel out, and let's see, 3 goes into 180 60 times, so it looks like we get negative 60 degrees. So the big thing to take out of this slide is that if I'm converting from radians to degrees, I'm going to multiply by 180 over pi. Right now I want you to try this multiple choice question, convert this angle to radian measure, and we will go over this tomorrow in class. Be sure to put your answer into the Google form.